Hi everyone, and welcome to another episode of C++ Crash Course. My name is Nick, and today we're going to be going over one of the slightly more advanced topics in C++, and that's going to be templates. So we've seen previously that we can overload functions in order to have multiple things of the same meaning, but those things can have, if we have things that are maybe very regular in what they do, say if we want to have an addition function that takes integers, one that takes doubles, one that takes floats, one that takes characters, for example. It's still kind of annoying if all we're doing is say, add a plus b in each of those functions. There must be an easier way to do this. And the answer is yes, of course there's a way to do this. And that's what this thing called templates. So let's look at templated functions.cpp. So what is it? So let's first take a look at that normal example. So we'll take a look at overloading, which we've looked at previously. So we have two functions, both called sum overload. And it'll take an integer a, an integer b, and it'll return the sum of those two integers. The double one will do the same, but with doubles. Now, both of these functions do exactly the same thing. The only thing that changes is the data type. So what if we made the data type a parameter, just like we have, a and b as parameters? And that's exactly what templates do. So templates turn the data type into a parameter. And so what the compiler will do is it will generate code for us at compile time in order to basically create kind of these overloaded functions like we had previously. So the format or the syntax for a template is like this. So we'll have, let's actually zoom in. So we'll have template, and then the lesson sign, and then type name t. T doesn't have to be t, it can be whatever you want, but this is just what we'll use as an identifier for the type name. So here we'll have a return type of the type name. Then we'll have a two inputs of the type name, and we'll just add them together. So this will catch all cases of whether it's integers, whether it's doubles, whether it's floats or characters. We've got 4 lines of code that does it for all of them. So we don't just have to have we don't just have to have a single type name, right? Maybe there's times that we want to have, say, 2 different types be inputs to functions, and maybe those 2 different types will change. So we can do that right here and have multiple different type names as parameters, or a template using multiple different data types. So in this case, what we'll do is we will add or have an input of the type t and of the type u. We'll add them together, and then we'll return something of type u, right? So let's go ahead, and this will clear up more in the example, right? So we'll first have 2 integers, and we'll have 2 doubles, so ai and bi, and ad and bd. And so we'll just pick some random numbers, so 10 and 20, and then 1.234 and 6.678. So we see that we can, of course, use the overloaded functions, and they work exactly like we saw previously. And then we could also use the templated functions, and we can explicitly call the version of the template that we want by using this, using the less than and greater than sign with int. And so this will say use the int version of the template of the template on ai and bi, and then we can also do it with double and do the same. However, it's smart enough to be able to tell what the types of these things are. So if we just do sum of ai and bi, it will know to call the integer version. And if we do sum of ad and bd, the doubles, it will know to pick the double version of that template. Now, as a quick example, we can also see what happens if we use one with multiple different types. So here again, it will be implicit what gets called, and it'll be based upon what the input data types are. So in this case, t will be an integer, and then u will be a double, and then we'll flip it around, and we'll have this a be a double and b be an integer. And so this will return an integer, while this one will return a double, because u is the return type, which we can see up here, right? So let's go ahead and compile this. And make sure that it works. So we'll call g++-o on templated functions.cpp. There we go. Okay, no errors. and then templated functions. Right. All right, so let's see what happens here. So we use our overloaded functions, and we got the sum of two integers and two doubles. Then we also saw that we can do the exact same thing and explicitly call the type of a template. And then we did it with implicit, without saying that this is we want to call the integer version or the double version. And we saw that we could use multiple different versions or multiple different data types within one template. So in this case, this one added an integer and a float, or an integer and a double, and it returned a double. And this one added a double and an integer and returned an integer. So it got casted as an integer when it got returned, while this one was casted as a double when it got returned. So that's going to go ahead and do it for today. So that's going to be an introduction to templates. Templates are a very powerful thing. It allows us to really generalize our code and reduce a lot of repeated code. So over here on github.com/coffeebeforearch, we have our C++, our GPU programming, and our Python programming, all the code relating to those videos, as well as the slides and links to the videos for the research talks that I give on modern research papers called This Week in Architecture. So if we go to C++ Crash Course, we of course have my contact information over here, my environment setup, and then also all the previous videos and the files associated with those videos. So for today, we can go ahead and look at it in fundamental concepts and within templates, and we have templated functions.cpp. So feel free to download this, check it out, play around with it, and let me know if you have any questions. So as always, I'm Nick, and I hope you have a nice day.